Welcome back, everybody. Time for 3 difficult direct integration questions with initial or boundary conditions. First question, dy over dt equals ln 4t, with the boundary condition y equals 2 when t equals 1/4. First step is to multiply dt on both sides. Then, to make this look simpler, use u substitution with u equals 4t du over dt equals 4 and dt equals du over 4. We plug this back in. Then, evaluating the left side gives y, and the right side is the integral of ln u, which can be found using integration by parts. To give u ln u minus u plus c, we can back substitute the value of u to get the equation in terms of t. Then, distribute the 1/4 inside the brackets. Finally, to find c, we plug in the boundary condition, which gives 2 equals 1/4 ln, 4 times 1 over 4, which is 1 minus 1 over 4 plus c. ln 1 is just 0, so c equals 2 plus 1 over 4, or 9 over 4. Plugging this back in gives the answer. Y equals t ln 4t minus t plus 9 over 4. The next question is a separable equation. X times x minus 1 times dy over dx equals y times y plus 1, with the boundary condition y of 2 equals 2. We can begin by cross-multiplying. Let's keep the y terms on the left side and the x terms on the right. Then we can integrate this. However, there does not appear to be a clear-cut way to integrate this. Therefore, we use partial fractions. To learn more about integrals and how to choose which method to use, make sure to visit our integration practice series. Let's do partial fractions for the left side first. The expression can be rewritten as a over y plus b over y plus 1. Multiply both sides by y times y plus 1. We can solve this by choosing y values that help simplify the expression to find one of the constants. Choosing y as 0 gives a equal to 1, and choosing y as -1 gives b equal to -1. We do the same for the right side. An equivalent expression is c over x plus d over x minus 1. Multiply both sides by x times x minus 1. First, choose x as 0 to get c as -1, and choosing x as 1 gives d equal to 1. Now we have expressions on both sides which can be integrated. Evaluation gives us ln y minus ln y plus 1 equals negative ln x plus ln x minus 1 plus c. Both sides can be simplified due to the logarithmic properties. If we have a subtraction sign between two ln terms, then they can be written as a single ln term with the values inside the brackets being divided. The boundary condition can be plugged in. Both x and y are equal to 2. This gives ln 2 over 3 equals ln 1 over 2 plus c. Yielding the value of c to be ln 4 over 3. This can be plugged back in. Then we have a plus sign between the two ln terms on the right, so the insides will multiply. Then log inverse can be taken on both sides to get rid of ln. And some basic algebra at the end gives us the answer. Y equals 4x minus 4 over 4 minus x. Time for the most difficult question for today. Cos power 4 of x times dy over dx equals sine cubed x, with the condition that y equals 8 over 3 when x equals pi over 3. As usual, we start by cross-multiplying. Now integrate both sides. The left side yields y, while the right side, Does not look that good. However, we recently taught a trick for solving similar-looking integrals, so make sure to check that out. There are a couple of methods to solve this, but we will use the best, most simple method, starting by rewriting this. Sine cubed over cos cubed can be written as tan cubed, whereas the leftover cos in the denominator can be written in the numerator as secant x. Here we have trigonometric terms being multiplied while having a power greater than 1. Therefore, we use trigonometric identities. Tan squared x is equals to secant squared x minus 1. Which enables us to use u substitution. Choosing u as secant x gives du over dx as secant x tan x, and dx as du over secant x tan x. Then our secant and tan terms cancel out, leaving us with the integral of u squared minus 1, which is evaluated to gives u cubed over 3 minus u plus c, and back substituting u to get secant cubed x over 3 minus secant x plus c. Lastly, the condition is used. Cos pi over 3 is just 1 over 2, therefore secant pi over 3 is 2. So 8 over 3 equals 8 over 3 minus 2 plus c, therefore c equals 2. So the final answer is secant cubed x over 3 minus secant x plus 2.